Hi everyone, welcome to how to use a breadboard.
So this is our breadboard here, and the breadboard is divided into three sections. We have a power rail along the top, a power rail along the bottom, and then the section in the middle where we build our circuit. So firstly, with the power rail, in the two power rail sections, the dots are connected in a horizontal manner with a break in the middle. So to give you some examples, if I place these two wires in these holes, the red and the green wires are connected. However, the dots are only connected in a horizontal manner. So these two wires here are not connected. Similarly, because there is a break in the middle, this wire here is also not connected to the green wire. So when we're prototyping with our breadboard, it's generally a good idea to place a jumper wire along the middle here. So now when we want to use any part of the breadboard, we can always get power from our power rails. And we should always do the same thing with our ground rail as well. In the middle section, the dots are connected slightly differently. So the dots are connected in vertical groups of 5. So we have two lots of vertical groups. So again, with some examples, if I plug a wire in here and a wire in here, these two wires are connected. However, it won't be connected to the dot that's horizontally adjacent to it. Similarly, if we place it in the same column but on the bottom half, these will also not be connected. So the other feature our breadboard has is the two terminals on the left-hand side. So what we'll do here is when we want to connect power to our circuit, we'll place our alligator clips onto those knobs, and then we connect using a wire along the bottom into our horizontal rails to distribute power through our board. So this is why we call these rails our power rails.
Now let's draw a circuit with 3 simple resistors and transfer that onto our breadboard. So we'll start with our power, and we'll put 1 resistor in series and another 2 in parallel, like that. So that's where your voltage goes through, and here is, let's say, a 1K, and then we'll put a 10K parallel with 150 ohms. And let's transfer that onto the breadboard next.
Okay, so now let's take that circuit that we've drawn and make it on our breadboard. So we're going to start by connecting our battery into the main part of the circuit. So in this case, our battery is going to be coming from the terminals. So we're just going to connect our power rail down into the main part of the breadboard like that. Now we're going to grab our 1K resistor. I'm going to place it in like this, connecting it to the power because it's connected vertically there. Now we have to connect 2 other resistors in parallel. And we do that by making sure both leads plug into the same vertical set of dots. Okay, and then finally, we need to connect the end of those resistors down to ground, like that. Okay, so now let's plug in our power cables into our terminals like this. And then we plug the other end over here into our power supply. Okay, so now let's turn on our power. And then we press the output. Okay, and now our circuit's working. So now we're going to rebuild this circuit in a couple of different ways to show you the same circuit diagram can be made in many different ways on our breadboard. So there's another way. Okay, and there's another one. Okay, and there's another way. So while this circuit is equivalent to the circuit diagram we've drawn, we don't recommend building your circuits like this because it's very complicated, which means there's more places that the circuit could break, and also you're more likely to make a mistake when you're building it. So this is another way we can do it. Once again, we don't recommend doing this because we have lots of exposed wire which could short against other things and break your circuit. Okay, so one thing we can do to make this circuit a better choice of circuit to use is to cut our leads so all our resistors are flat against the board, and then this circuit would be an okay circuit to use. So now our circuit is a lot neater and a perfectly good circuit to use. Okay, so another thing we might like to do with our breadboard circuits is have a circuit with an IC in it. So if we put an IC in our circuit board, we put it over this middle gap here. Like so. So the reason why we do this is so that none of the pins on our IC are shorted out to any of the other pins in our IC, and each IC pin has its own row of 5 dots to connect stuff to. So one of the really common errors people make when they're putting an IC in their breadboard is they'll put it in like, well, they'll actually get it in. So they'll put it in the breadboard like this. Now the problem with doing this is, because all our rows are connected, all of the pins on either side of the IC will be connected together, which means our IC won't work properly. Also with resistors, another common mistake is to connect the resistors like this. So once again, we've accidentally connected the bottom lead of both ends of the same resistor together, which means this resistor will be short-circuited and won't do anything.
Now let's draw what's just been put on the breadboard. So we have our resistor, and it's being short-circuited. You can see that this vertical line on the diagram actually represents the inner electrical connections on the breadboard. So you can see how that resistor won't work.